So, it's time now to look at how we factorise difficult quadratics. In the previous part, we learned there's a trial and error method you can use in a situation like this, where there are only two real options for the first bracket, for the first terms, and two real options for the last, which creates few combinations. We also talked about a situation where if the numbers were far trickier, we could end up with a huge number of combinations to check. This is unfeasible. So, let's look at the following. This is a generic bracket that has been factorised. So I'm going to expand this quadratic now with you. I'm going to look at the answer. So it's this whole bracket times x and this whole bracket times b. If this isn't the method you use for expanding brackets, then you'll need to bear with me and just wait for the result in a second. Now, those are both x terms. I've got a lots of x and b lots of x. So what do I have? Well, I've got a plus b lots of x. If this was 2x and this was 5x, you would add them here to get 7x. So, look at what we started with. If I have a and b here, look at this. The number on the end is where I multiply them, which we know already, and the x term is where I add the numbers on the end, which we know already. Now we're going to take this rule here and go one step further. Let's just see that clearly again. The two numbers times to make the n number, and the two numbers add to make the number of x's. Now, how are we going to generate the first number where it's not just x squared? Well, I need to have some number of x's and possibly a number there as well. And that's because if it was 16x squared, this could be 4 and 4, 8 and 2, 16 and 1. We just don't know. If you want to have a go at expanding it yourself, pause the video now and try. And a reminder to always pause and try yourself if you wish. So, the whole first bracket times cx. And the whole first bracket times d. Okay. Cx times ax is acx squared. Cx times b is bcx. Just put in the letters in alphabetical order. Dax is adx and db on the end. And then we're going to have a look and see what we can do with this. So we've got one x squared term, so that's going to stay as it is, and one number term, because remember that d and b are just numbers, so this is just a number. Now, these are both x terms. If this was 2 and this was 5, you would add them. So we're going to add BC and AD and get how many lots of x we have in total. If this was 3 and this was 5, you'd get 8 here. So, how do we make this work? the middle number? Well, that's this pair and this pair added. That's a bit hard to work out. This number is this pair multiplied. And this number is this pair multiplied. Let's take a look at this and compare it to this. So this one is a pair of things added. And then it's the last one. This one is a pair of things added. Can we get that same pair of things multiplied somewhere else? Can we get BC times AD? Now, when it was just A plus B, it was on the end. Where can we get BC times AD from? Remember, that is B times C times A times D. All 4 letters multiplied together. Can we get that from somewhere? Here are those pairs added. All 4 multiplied we could get by multiplying these 2. Now, that seems like a change from before, but let's check. This is the pair added. What happens if we multiply these 2? Well, this is 1, so the pair makes AB, so it works. This pair, AC times DB. Well, that's 4 things all multiplied. Multiplication works in any order, so we could rewrite it as the question gave us. Let's go through that again, just to make sure. This term is these pairs added. To find these pairs multiplied, like we did here, we looked at these 2, because we can reorder them and make the pairs we want. So, when we have a quadratic like this, we're looking for a pair of numbers that add to make 5 and a pair of numbers that multiply to make 6. What are those pairs of numbers? Well, you've probably spotted it's 2 and 3. But how does that help us right now? Well, it means that, the top one means that BC plus AD makes 5. And the bottom one says that BC times AD makes 6. How can we use that to put this into brackets? Well, it's not as easy as it seems, is it? So we don't know which way around the 2 or the 3 go. And of course, AD and BC are made up of 2 terms. So let me show you how it works. What we've just learned is that we're going to multiply to make 6 and add to make 5. And it gave me 2 and 3. And 2 and 3 actually are the pair of x terms that make the 5. So let's write it like so. Let's write 2x plus 2x plus 3x plus 3. There is our 5x split into our 2 and our 3. Now, how can we factorise this and make it into 2 brackets? So, look at the first 2 terms. They have a 2 and an x in common. What does that leave to go in a bracket? It leaves an x and it leaves plus 1. What about the last 2 terms? They have a 3 in common, and that gives me x plus 1 again in the bracket, which, when I now try and combine this, I've got this many lots of this and this many lots of this, so I've got 2 brackets. So, by recognising the 2 terms that add to make 5 that we need are 2 and 3, I can split the 5x. By splitting the 5x, I can then factorise in 2 pairs and then bring it all together in 1. Now, this might look strange to some of you, and perhaps there's a particular approach to expanding brackets that you need to look at in order to make sense of this, because it's not how all of you do it. In part 5, we looked at the inspection method. So we start with 2 brackets. We do this bracket times x and this bracket times 5. So look at that line there. It's x lots of this and 5 lots of this. 2x lots of this and 3 lots of this. Now we've taken it here from the brackets to put it in this format. Here we're taking it from the single brackets into the double brackets. So we're going this way. Can you see how that step works? So now go look at here at how we expand again. We would then multiply the x by this bracket and the 5 by this bracket. Up here, how we got to these single brackets was we took the 2 pairs of terms and factorised them separately. So the opposite step again. Look from here to here. Expanding the single brackets, whereas we're putting it into the single brackets. Then the last step is simplifying that middle term. And we've been doing that in every one of our examples in all the different methods. Not just here in inspection method. We also here collected our x's together to make our middle term for the grid method. So, what we did differently here, in factorising this to here, is in here we knew the start terms, so we knew how to combine these. The 3x and the 5x became 8, whereas here we worked out a way of splitting our 5x by looking at they times to make this pair and add to make this one. And when we worked out how to split it, 2 and 3, we then factorised. Now, that's a very difficult topic to get your head around. And I think what we'll do is, in the next part of the video, we're going to look at some examples of using this. But let me just say it one more time. So, outer multiply to make, inner adds. Then you find the pair, split the x term, factorise your pairs, and factorise fully. If you want to pause now and look through that, go do so. If you feel happy, prepare to do some more examples.